Good morning, students. Today we are going to start part 2, and the chapter which we are going to start is your chapter 9, Ray Optics and Optical Instruments. Now, in the revised syllabus, few topics are deleted, and we are not going to discuss the deleted part. Please go through the revised syllabus. Now, the topic which you are going to discuss is your refraction of light. Now, all of you know what is refraction. You have got in lower class, in class 10. Now, let me read out what we have written. When light enters from one medium to another medium obliquely, its path changes. This phenomenon is called refraction of light. So, whenever light enters from one medium to another medium, the direction of movement of the light changes, and this phenomenon is known as refraction of light. This basically happens due to the change in the velocity of light. Now here in the diagram, we have considered an interface separating the two medium. N1 and N2 is the refractive index of first medium and second medium. So we have drawn a normal. Normal makes an anti-degree with the interface. Now a ray of light strikes at the interface with an angle of incidence I with the normal. Now as it moves from one medium to another medium, its direction changes, and the angle made by the refracted ray with the normal is your smaller. And this phenomenon, this change in direction of the light when it moves from one medium to another medium, is known as refraction of light. Now here we are considering light moves from rarer to denser. That's why it bends towards the normal. Now there are laws related with the refraction. I think there are two laws basically. Number one law, the incident ray, refracted ray, and the normal all lie in the same plane. So the incident ray, the ray which strikes at the interface is known as incident ray. It makes an angle I with the normal, that is your angle of incidence. And the ray which changes the direction of movement when it moves from one medium to another medium is known as refracted ray, and it makes an angle R with the normal. So the incident ray, the refracted ray, and the normal all lie in the same plane. So this is your first law. And the second law is the sine of angle of incidence to the sine of angle of refraction is constant, and the constant is refractive index of the second medium with respect to the first medium. So sin I by sin R is constant. Sine is a trigonometric term. Sin I by sin R is constant, and that constant is the refractive index of second medium with respect to the first medium. And basically it is denoted by the subscript and superscript, that is N21, refractive index of second medium with respect to first medium. Now if someone asks you what is refractive index, then you can define by considering sin I by sin R, which is nothing but the Snell's law, and this is nothing but the relative refractive index because you are considering two medium. Now if someone asks you what is absolute refractive index, in absolute refractive index basically what happened, we are considering one medium is your air and another one is any medium. So definitely refractive index of that medium is nothing but the absolute refractive index, and the formula is your N equal to C by V, and C is your speed of light in air, and its value is your 3 into 10 to the power 8 meter per second. Now N21, that is refractive index of second medium with respect to first medium, you can write by mathematics, that is your N2 by N1. Now you can apply absolute refractive index formula N2, that is C by V2, and N1 is your C by V1. So if you simplify, it is your V1 by V2. So this kind of formula is applicable in numericals, that's why I have given here. You can go through the textbook for the related formula. And the third point, you must have to remember, the refractive index is always for denser medium. Here we are considering rarer to denser. The denser medium is your second medium. Now let me try to discuss this one. This is your total internal reflection. Now you see in this figure, we are considering number one ray. It strikes at any angle at the interface, and here the rays moves from denser to rarer. So one correspond to one dash, that is your one is your incident ray and one dash is your refracted ray. So we are slightly changing the angle of incidence, and corresponding the angle of refraction also changes. 2 is the incident ray with the angle of incidence more than the angle of incidence for 1. So 2 dash is your corresponding refracted ray. Now if you in this way, if you change the angle of incidence, correspondingly you will see the angle of refraction also changes. Now you will see that for every pair of medium there is a particular angle of incidence for which the angle of refraction is your 90 degree. So here ray number 3 and 3 dash. 3 is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is your 90 degree. And this angle of incidence for which the angle of refraction in the rarer medium is 90 degree is known as critical angle for the pair of media. Why it is known as critical angle? Because if you slightly increase the angle of incidence above the angle of critical, that is angle C, what happened? The whole phenomenon reverses. Because for 1, 2 you are discussing refraction, but if you slightly increase the angle of incidence above for the ray 3, that is more than C, what happened? The phenomenon comes to be reflection, because both 4 and 4 dash is in the same medium. So in the same medium, we know that is nothing but the reflection. So as the phenomenon changes, that's why this angle is known as critical angle. Now you can apply for number 3 ray your Snell's law. Snell's law is your sin I by sin R, that is sin C, and that one is your sin 90 degree. Sin C, because this part is your incident part, sin C by sin 90 degree, and equal to refractive index of second medium means n2, n1, and 2 is your rarer medium. So sin C, if you simplify and if you reverse, then it becomes n12. n12 is nothing, n21 is nothing but the 1 by n12. n21 is nothing but equal to 1 by n12. It means if you change the medium, then automatically it becomes reciprocal. So where C is the critical angle. So here n12 is nothing but the refractive index of the denser medium, because it's the first medium, and first medium is your denser medium. So in general, in critical angle, you will get the formula sin C equal to 1 by n, and n is the refractive index for the denser medium with respect to rarer medium. So under note, let me read out, critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree, and critical angle is constant for the pair of media. Now let me read out the important part which we have started, the total internal reflection. Already we have discussed here with respect to this figure. So let me read out the phenomenon of reflection of light when the light traveling in a denser medium strikes the interface separating the denser medium and the rarer medium at an angle of incidence greater than the critical angle is called total internal reflection. Okay, I think you have understood. It's very simple. Now there are many applications of total internal reflection. So here we are considering 3 applications: mirage, looming, and brilliancy of diamond. In mirage, basically what happened, ray moves, means in desert basically mirage occur. So the ground surface is hotter compared to the surface of air above the ground. So if you consider as we move up, basically what happened, we are getting rarer medium. So I think a total internal reflection occurred there, and as a result of total internal reflection, traveler sees a pond very far, but when that traveler reaches that place, that person sees that no pond is there. So this phenomenon is known as mirage, because why pond seems, because image comes in downward in the sense and downward on the surface itself, because if you see the image near a pond, the image seems to be inside water, is not it? If you consider a tree near the bank of a river, you will see the image is inverted image comes out. And similarly in case of looming basically what happened, the surface is colder. As we move up, we are used to get hotter air. So there is also possibility of total internal reflection, but it is the reverse of the mirage. In mirage, the ground surface is hotter. As we move up, it becomes comparatively cooler. But in ice cold place, basically, the ground surface is cooler, and as you move up, it becomes hotter. So whenever this kind of difference in medium exists, you will get total internal reflection. And third one is your brilliancy of diamond. So it comes from the critical angle part. So please go through these three phenomena if you want to know in details in your textbook. So this is all about. Please go through and try to find out your queries and put your queries if you have. So we have started part 2. So this is all about for today's class. Thank you.